Welcome to the Deep Dive, where we take a stack of information and extract the most important nuggets to get you well-informed, quickly. Today, we're tackling a really major challenge with large language models,
Uh-huh.
or LLMs. It's their tendency to sometimes hallucinate
Yeah.
and confidently make up facts.
Oh, absolutely. It's a well-known issue.
And while the field's made strides, right, like with retrieval augmented generation, RAG,
Mm-hmm.
giving LLMs a kind of reference library,
Yeah.
and then GraphRAG adding structure.
That's right. Adding structure to that knowledge.
But sounds like some really sticky problems still remained.
That's absolutely right. Despite their incredible success, factual consistency in LLMs, particularly, when you need them for knowledge-intensive tasks, that remains a key hurdle. Traditional RAG, like you said, often just retrieve chunks of text, kind of isolated pieces.
Right.
And even GraphRAG, which, yes, added structure, still faced some significant limitations.
So I'm picturing trying to understand something complex just by reading random paragraphs.
Yeah.
Or maybe looking at a map that only shows, like, simple A to B connections.
Yeah, you miss the nuances.
You miss the deeper relationships, the context.
Exactly. That's a big part of the limitation with those earlier approaches.
Okay. And this is precisely where this new framework, GRAPH-R1, comes in.
Correct. It aims to fundamentally change how LLMs can reason through complex knowledge.
So our mission today is to really unpack how GRAPH-R1 works, why it's, well, potentially a significant leap forward, and what that might mean for getting more reliable AI. So if GraphRAG was already an improvement, adding that structure, what were the lingering roadblocks? What did GraphR1 need to overcome?
Yeah, there were essentially three main challenges that were holding back the existing GraphRAG methods.
Mm.
First, the high cost and potential semantic loss, basically converting natural language into these rigid graph structures. It could be expensive, and sometimes you'd lose some of the original meaning in translation.
Like flattening the nuance.
Exactly. Second, the retrieval process itself was often fixed, a one-time shot. Current GraphRAGs tried to grab all the knowledge they thought they needed in one go. But for complex questions that need multiple steps, that's just not very efficient or effective.
Right. You might not know what you need until you see the first bit of info.
Precisely. And third, there was a heavy dependence on really large LLMs.
Okay.
You needed these huge models for the long context analysis and very careful prompt design. And even then, the reasoning could be unstable. The output quality could vary.
Okay. Those sound like pretty significant hurdles. So GraphR1 isn't just a minor adjustment then. It's bringing in, you said, agentic behavior and reinforcement learning.
Yes, it's a fundamentally different approach.
So what's the core shift here? What are these innovations really doing for the LLM's ability to actually reason?
Okay, so GraphR1 introduces three key advancements that really work together. First, there's a lightweight knowledge hypergraph construction method.
Hypergraph. Okay, what's hyper about it?
Right, so think beyond just simple point-to-point connections like A connects to B. A hypergraph can represent more complex relationships where one edge or link can connect multiple nodes, multiple pieces of information, all at once.
Ah, so like representing a whole event with multiple people involved, not just pairs.
Exactly. It's a richer map of knowledge. And crucially, this method builds this richer map in a much more cost-effective way. It's more nimble.
Okay, a hypergraph, that sounds powerful. Capturing more complex links. What's the next innovation? How does it use this hypergraph?
So, second, GraphR1 models the retrieval process itself as a multi-turn agentic interaction.
Agentic interaction, meaning?
Meaning, instead of that single retrieval attempt we talked about, the LLM agent goes through a loop. It's like, think, retrieve, rethink, generate.
So it asks a question, gets some info back.
Right. Then it analyzes those results, maybe formulates a new, more refined question based on what it just learned, and keeps digging.
Like a researcher or a detective following clues.
Exactly like that. It keeps going until it feels it has the full picture. This makes the whole process much more robust, especially for those complex, multi-layered questions.
Okay, that multi-turn interaction sounds genuinely revolutionary. It's not just looking things up, it's strategizing its search.
Precisely. It's active, iterative problem solving. It learns as it goes.
Okay. And the final piece, you mentioned reinforcement learning.
Yes. The third key part is an end-to-end reward mechanism using reinforcement learning, or RL. What this does is integrate multiple factors, the quality of the final generated answer, the relevance of the stuff it retrieved, and even the sort of structural reliability of the paths it took through the hypergraph, all into one single optimization goal.
So it gets rewarded for doing the whole process well. finding good info, using the graph smartly, and writing a good answer.
Exactly. The agent essentially learns, through trial and error and rewards, how to reason effectively over this hypergraph structure to generate accurate answers. It tightly aligns that structured knowledge with the natural language generation.
And you mentioned this was inspired by other RL work.
Yeah, the paper mentions inspiration from systems like DeepSeek R1, which also use RL for similar complex reasoning tasks.
Okay, these are definitely big claims. Building a better map, using an agent to explore it iteratively, and teaching it with RL. Did these innovations actually, pay off? Did they translate into better performance in practice? What did the experiments show?
Well, the experimental results reported are quite compelling. They really seem to demonstrate a clear advantage. GRAPH-R1 consistently outperformed not just the traditional GraphRAG methods, but also other attempts at using RL-enhanced RAG across, I think it was 6 standard RO benchmark datasets. Things like Hotpot QA and Trivia QA.
Consistently better is good. Can you give us a sense of the scale? Like how much better? Do you have any specific numbers?
Sure. So, for example, using a specific model, a 7 billion parameter Quen 2.5 model,
Right.
GraphR1 achieved an F1 score of 57.28. And just for context for listeners, F1 score is a standard way to measure accuracy, balancing precision, and recall basically how right the answers are and how complete they are.
Got it. So 57.28, how does that compare?
Well, standard RAG, just using chunks, got 32.05 on the same test. Hypergraph RAG, an earlier graph method, scored 29.4.
Wow, okay. That's a big jump.
It is. And even other advanced RL methods they compared against, like one called Search R1, only reached 46.19.
So GraphR1 is significantly ahead even of other RL approaches.
That's what these results suggest, yeah.
Yeah.
It really seems to indicate that this specific combination, the reinforcement learning with the graph structure, used in this agentic way, truly unlocks the power of graph representations.
That's fascinating. It's not just having the graph, but how the agent interacts with it using RL. Did the size of the underlying LLM make a difference for GraphR1?
Yes, absolutely. They tested that. As the base model size increased, they went from 1.5 billion parameters up to 3 billion and then 7 billion. GraphR1 showed steadily higher F1 scores. It went from about 40 up to 51 and then hit that 57.82 with the 7B model.
Okay, so bigger models do help GraphR1 perform even better.
It suggests that the larger models are just better equipped to leverage that synergy, Between the complex graph structures and the reinforcement learning signals within the GraphR1 framework, they can make better use of the whole system.
And what about the individual pieces? You mentioned the hypergraph, the multi-turn interaction, the RL. Did they all contribute significantly? Did they run tests taking parts away?
They did. Those are called ablation studies.
Right.
And yes, the studies confirmed that if you removed any one of GraphR1's core components, whether it was the specific hypergraph construction or the multi-turn interaction or the reinforcement learning layer, performance dropped noticeably.
So they all pull their weight. It's the combination.
Exactly. It highlights that each innovation really makes a critical contribution. It's the whole package working together.
Okay, these results are genuinely impressive. But, often advanced systems come with trade-offs. Does GraphR1 come with a hefty computational cost? Or does it take ages to generate an answer?
That's a fair question. But surprisingly, no. The paper reports remarkable efficiency, actually, both in terms of cost and speed. For constructing that knowledge hypergraph in the first place, it apparently only required about 5.69 seconds and cost $2.81 per 1,000 tokens of input data, which they state is lower than previous methods like GraphRAG and HyperGraphRAG.
Lower cost to build a graph, okay? And for actually answering questions.
For answering queries, the response time was reported at just 7.0 seconds per query.
7 seconds. That's pretty quick for a complex query.
It is. And interestingly, the cost for generation was listed as $0.
$0 for generation. How does that work?
I believe it implies the generation itself, using the pre-trained base LLM guided by the RL policy and retrieved context, didn't incur additional API costs in their setup, unlike maybe methods that rely heavily on prompting a separate, larger model for synthesis. This again outperformed HyperGraphRAG, which took longer, 9.6 seconds, and had a reported cost of $8.76 per query.
Wow, faster and cheaper to run. That's incredibly practical for actually deploying this kind of system.
Definitely makes it more feasible.
And what about the retrieval itself? Since it's doing multiple turns, does it end up retrieving way more information than needed? How efficient is that part?
That's another interesting point. GraphR1 actually excels in retrieval efficiency. Even though it might conduct more interaction turns, they found around 2.3 to 2.5 turns per query on average.
Okay.
It tended to generate shorter final responses, typically around 1,200 to 1,500 tokens.
So more turns, but more focused retrieval each turn.
Exactly. That multi-turn strategy seems to allow it to balance things really well. It gets the information it needs precisely without fetching excessive amounts of irrelevant context. This leads to more stable and ultimately more accurate retrieval.
Right. Smart searching, not just wide searching. Okay. The ultimate test, though, is always the quality of the final answer. How did it stack up there? Correctness, coherence.
It scored highly there, too. They evaluated on several dimensions. Correctness was reported at 86.9%, relevates at 95.2%, very high, and logical coherence at 88.5%.
Those are strong numbers.
They are, and they highlighted a specific case study which I found quite telling. The query was, who is the spouse of the director of the film in memory of Sergo Ardonikids?
Okay, that's a multi-hop question, right?
Oh.
You need to find the director first, then find their spouse.
Exactly. It requires connecting multiple pieces of information.
So how did GraphR1 handle that compared to others? That
Yeah.
sounds like a perfect test for its detective work.
Well, in that particular challenging example, they found that many other systems, even some of the other RL-enhanced ones like SearchR1 or methods based on models like GPT-4 or Mini, they really struggled.
What happened? Did they get it wrong?
Some hallucinated the director's name. Others just said the information wasn't available or couldn't be found.
Okay. And GraphR1?
In stark contrast, GraphR1 successfully navigated the query. It first correctly identified the director as Dziga Vertov,
Right.
and then, using its multi-turn reasoning process over the hypergraph, it correctly found his spouse, Yelizaveta Svilova, and delivered the precise answer.
Wow. So it followed the chain of connections accurately.
Yes. And this example really showcases, I think, how much more effective that reinforcement learning becomes when it's combined specifically with the structured graph-based knowledge representation. The structure guides the RL agent.
That's a fantastic example of that intelligent navigation. Okay, so it handles specific, tricky questions well. But what about generalizing? How well does GraphR1 adapt if you throw new kinds of questions at it, or questions from different domains it wasn't explicitly trained on?
That's crucial for real-world use, definitely. And here, too, GraphR1 demonstrated strong robustness and cross-domain generalizability. It performed well even in what they call out-of-distribution settings, basically, testing it on data significantly different from its training data, across diverse datasets like natural questions and trivia QA.
And how do they measure that?
They looked at the ratio of its performance on out-of-distribution data compared to its performance on in-distribution data, OOD to IID ratio. Those ratios were consistently high, often above 85%, and in some cases even exceeding 90%.
So it maintains most of its performance even on unfamiliar territory.
Exactly. It means it's not just good at answering questions similar to what it's seen before. It seems genuinely adaptable and robust when faced with new types of information or new domains. That's really important.
Okay, so let's try and wrap this up. What does this all mean, big picture, for you, the listener, and maybe for the future of AI? It sounds like GraphR1 is a pretty significant step.
I think it is. It represents a significant move towards making LLMs not just powerful predictors of text, but genuinely more reliable reasoners.
By connecting that structured knowledge, the hypergraph, with that adaptive reinforcement learning.
Exactly. It seems to bridge that gap between just having access to raw data and being able to produce coherent, accurate answers that require understanding the relationships within that data.
So LLMs that can engage in this kind of multi-step reasoning, more like how humans tackle complex problems.
That seems to be the direction, leading to potentially higher accuracy, definitely greater efficiency, as we saw, and better generalizability. And that's just crucial for any application where you really can't afford factual errors.
Yeah, where consistency is non-negotiable. Finance, medicine, science.
Anywhere trust is paramount. It's
Yeah.
moving AI from just sort of pattern matching or recalling facts towards a deeper understanding of how those facts connect.
So connecting this to the bigger picture, you can start to imagine AI that doesn't just know a vast amount, but can navigate it strategically, iteratively, almost like a human expert does.
That's the promise, isn't it?
Yeah. This deep dive into GraphR1 really shows us how close we might be getting to AI systems that don't just know things, but can actually reason about their relationships. So maybe a final thought for everyone listening. What new complex problems might you tackle, or what questions could you finally answer if you had a tool that could reason through information with this kind of depth, accuracy, and structured understanding?